I want to tell you guys that I'm very proud of you during the rewind because that is a very difficult problem and you guys all just did very well on that. So if you were explaining to somebody who maybe wasn't quite sure, I saw a lot of collaborating and working together, which just makes me very proud. So if you were explaining to somebody who wasn't sure where to start, what would you tell them? What would you tell them? Isabel? Okay, so we're working with this point, all right? And then what else? It has to be parallel. So Desiree, since it has to be parallel, what's the slope in this equation? Which number is the slope? The 3 or the 4? The 3. And since it's parallel, that means in your other equation, your slope should also be 3. Exactly the same. What if that word were perpendicular instead of parallel? I want to ask Belle that. What would you do if I said perpendicular instead of parallel? What did you do? What would you do if instead of saying it was parallel to this line, you made it perpendicular? What would change about the slope? You would make it negative, and then it would be negative what, Daniel? Opposite reciprocal. Very good. So in this case, we went with the same. So then you plug it into what format? Yeah, point slope form. Y minus y equals, how come we use point slope form when it's asking for slope intercept form? It wouldn't fit because we don't have an intercept, right? So we put it in y minus what? 4. All right, so the only thing that would change if this said perpendicular, what's the only number that would change? The 3 would become negative 1/3. Very good. Okay, so if it were perpendicular, it would say negative 1/3. Otherwise, we still do the same thing. So what do we do next? Distribute the 3. And distribute means what kind of math? So that gives us, very good. And then last but not least, plus 4. How come I add it to the 6 and not the 3x? Like terms. 3x has a variable, so you can't put those together. So y equals 3x. Why is it minus 2 and not plus 2? 6 is bigger, and it's a negative sign. So we go minus 2. Very good. All right, awesome job. So that was the rewind. That's going to be probably one of the bigger questions on your test, which will be Friday. Friday. No, this week.
2 weeks from now.
What do you want to just, like May. Yeah, sometime in May. All right. No, Friday. Your test is going to be Friday. We'll review Thursday. We will Kahoot, then test on Friday, okay? So we will do review on Thursday, then Kahoot first hour on Friday, test second hour, okay? I like Kahooting right before the test. I think it's good for you guys. Is Kahooting a verb? No. No?
You made it a word.
All right. It's going to be. Ashley?
College freshman.
That's in March. The freshman college visit?
Freshman college day.
The what?
Freshman college readiness. Yeah.
On Thursday you do, but we still have algebra class. So I will see you for 1 hour on Thursday where you'll do the review. And then on Friday you will Kahoot test, as opposed to my other class, which will do review Kahoot on Thursday.
Wait, so we got you in the morning, right?
On Thursday, Fridays? Yes. Yes.
Oh, man,
I just show up, and whoever shows up here I teach. I don't even know. Yes, I like it also. Okay, let's get started. So we are going to talk today about transforming linear functions. This is the last part of this unit because it's you need to know a lot of stuff that we have learned so far to be able to understand this. Not that it is that difficult to understand, just that there is a lot of stuff that you need, what we call prior knowledge. You guys need a lot of prior knowledge. But when we work through this, I want you guys to notice that what's really important to know is where slope is in your equation and where the y-intercept is in your equation if it's in the format y equals mx plus b. So remember, which of these means slope? M. M is our slope. So whatever is right next to the x, that's going to be your slope. And then what is b? The y-intercept. What if there is no b? What if there is no b? It's 0. So if there is no b, the y-intercept is 0, which means that graph starts where? At the origin. All right, at the 0 at the origin. Okay, so that's our prior knowledge. Let's talk about parent functions. All right, so a function, a family of functions, is a group of functions whose graphs have some characteristics in common. So this right here is a family of functions. We have the purple, the green, the blue, and the red. The blue function is called the parent function. It's called the parent function because all of the other ones, the children, all of the other ones are just some transformation of the parent function. And what do you think I mean when I say transformation? What do you think I mean? What does the word transformation mean? Not like algebraically, just in general, what does transformation or transform mean? To change, right? So this blue is our original function. Why do you think it's the original one? Why is the blue the parent function and not the red, the green, or the purple? It goes through the origin. So it appears like it's the longest on this graph. All right, it goes through the origin. And then what's the slope? 1 over 1. All right, so the slope is 1 over 1. It's the parent function because it goes through the origin, and the slope is 1 over 1, which means the equation of that line is just what? Is just what? What does this mean? Daniel, instead of writing f of x, what could you write? Y. So this equation is just y equals x. Because what's the slope? You told me the slope was 1. And then if it goes through the origin, the y-intercept is 0. So do you need that 1 or that 0? No. So the equation can be written just as f of x equals x. Okay? Now, let's back up. Every time you see f of x, you can cross it out and just write y. Same goes here. Every time you see h of x, you can cross it out and just put y. K of x, cross it out, just put g of x, cross it out, just put. So why do we have f of x, g of x, h of x, k of x? Why do we have these things if we could just cross them out and put y?
So they won't use them with the other.
So you can tell them apart. Exactly. So when we first talked about function notation, I said you can always cross out the f of x and just put y. And some of you, I don't remember who, but I'm sure there was someone who was like, then why would you ever write it as f of x if you could just write it as y and make it way less confusing? Because if we want to talk about a family of functions, then this is a way to identify which one you're talking about without having to say the whole equation. Okay, so for example, how many of you have a bunch of siblings? Who has, John Jacob, how many siblings do you have? 7? Okay, and what if I just called you all by Tolliver? What if I was like, you're all in a room together, and we're having dinner, and I'm like, Tolliver, pass me the pizza. What would happen? You would all look, right? So what do I call you? John. And what do I call your brother who's a junior? Joel. Howell? Oh, man, I've been calling him Joel for 3 years now. All right. Well, in fact, so I would call him Howell, and I would say, pass me the pizza, right? So first names are a way of identifying family members that have the same last name, but we use first names to differentiate, right? That's what's happening here. This is a family of functions. They're all related to each other, and we know that, but we tell them apart by using different letters in their function name. So rather than saying y equals x, y equals this, y equals this, y equals this, we call this one f of x. Basically, this one's first name is f. We call this one g of x. Its first name is g. All right, this one's first name is h, and this one's first name is k. Okay, so function notation is just a way to tell functions apart so that we can talk about multiple functions at one time, and we don't have the whole Tolliver family looking at me at once. Okay? All right, so our parent function, f of x equals x. Now, we're going to talk today about 3 different transformations. We're going to talk about translations, we're going to talk about rotations, and we're going to talk about reflections. And we'll start by talking about translations. I want you to take a look at this blue line. What happens to transform, you guys told me that means to change, what happens to transform this blue line to this red line? Just visually describe to me what has happened here. It moved up. It moved up. It went from starting here at the origin to where does it start now? Up here at 3, right? Look at the graph. Then look at the equation. What's the difference between the blue equation and the red equation? It has x plus 3. So instead of just being x, when we translated, translate just means slide. When we slid it up 3, our equation became x plus 3. What happened to the green one? It slid down how many? So the equation became x minus 2. What happened to the purple one? It went down even more. How many did that go down? 4. So what happened to our equation? Our equation now is x minus 4. So when a translation is happening, on the graph what that means is you're sliding the line up or down. Does the slope of any of them change? No, and you know that because these lines are all what are parallel. The slope did not change, but the y-intercept changed. Okay, so my y-intercept changed, and that's how you can tell which way it was translated. And translate is a fancy word for slid. Slid up or down. Okay, so translation just means to slide up or down. So the way you would get this on a test or a quiz would be something like this. F of x equals x, g of x equals x minus 7. And I would say, describe for me the transformation. So there's two ways you could do it. You could either graph them, or you can look at the equations and know that what transformation happened. It's a translation. Which way? Down how many? 7. So your answer would be translate down 7. Or you could put like arrow 7. However you want to shortcut that, that's fine. Translating down 7. All right? So to go from the parent function to the child function, what happened here is it started at x here. Now it's starting at down here at negative 7 on the y-axis. So that's a translation. So you recognize translations because the y-intercept changes. All right. So looking at this one, f of x equals x and g of x equals x minus 5. Is this a translation? Yes, because did the y-intercept change? Yes. What was the y-intercept here? 0. The y-intercept was 0. There isn't one, so it starts at 0. And the slope is 1, so it just went like this. But what happened in g of x? It went down 5. Does the slope change? Nope, it's still 1 over 1. So how would you describe this shift? Translate down 5. All right, translate down 5. So the answer to this on a test or quiz would be translated down 5. Do you need to graph it? No? Does it help to graph it? It helps to see it, but some of you guys, how many of you guys think it's just as easy to tell just by looking at it? All right, some people might want to graph it. Some people just might want to look at the equation. Whatever way you want to do it is fine with me. It's going to be faster to just look at the equation, but if you're worried you might get it wrong, then go ahead and graph it. Okay? And how did we know the slope was 1 over 1? There's nothing in front of the x, so you assume it's an invisible 1. Good. Okay, so that's translating. All right, the next one we're going to talk about is rotating. So again, take a look at your blue one. That's your parent function. So that looks just the same, goes through the x, and it's straight from one corner to the other because the slope is 1 over 1. What's happening to make it the red one or the green one or the purple one? When we say rotate, what's like a simpler word for rotate? Twist or turn. Okay, so we'll call it a turn. All right, so rotate means you're turning that graph. When I turn something, if I turn it this way, does anyone know what the word is that we use to describe clockwise or counterclockwise? So to go from the blue to the red, which way is that turning? Counterclockwise. What does counterclockwise mean? Backwards from the way a clock turns, right? So a counterclockwise turns means backwards from the way a clock turns. So basically, if it's turning to the left, that's counterclockwise. If it's turning to the right, that's clockwise. Okay? So take a look at our equations then. The original equation is f of x equals x. The red one is g of x equals 3x. So what changed? Slope. The slope changed. In this case, what's our slope for the blue one? 1. What's our slope for the red one? 3. So it got bigger. And as it got bigger, it turned which way? Counterclockwise. So as slope increases, it's a counterclockwise turn. What about the purple one? What's our slope for the purple one? 1/2. So our slope for the purple one got bigger or smaller? Smaller. Which way did it turn? Clockwise. So as the slope goes down, if your slope is decreasing, that means it turns clockwise. So if your slope goes up, that's counterclockwise. If your slope goes down, that's clockwise. This is independent of negative signs. So ignore negatives when you're talking about rotating. You're just looking at the number. Okay? The way that I remember this, my little, I don't know if this trick will be helpful for any of you, but the way I remember this is if slope is increasing, increase means to get bigger. This is a bigger word. All right? As your slope is getting bigger, the word counterclockwise is bigger than clockwise. So if you have trouble remembering it, if your slope is getting bigger, use the bigger word. Okay? All right, slope decreasing means it's going clockwise, so turning to the right. All right, so if I give you an equation like this, f of x equals 2x, and g of x equals 1/2 x, that's an x. All right. What's the slope of f of x? 2. What's the slope of g of x? 1/2. Is that getting bigger or smaller? Smaller. So that means it's rotating which way? Clockwise. Clockwise. Slope is going down, means it goes clockwise. Okay, we're not going to do another example because my board needs to be reset. So I would like you guys now to go try the practice ones at your board. Hang on before you get up and move. There are 4 problems. What I want you to do is take a look at this. For number 20, what you would do is say, here's f of x, here's g of x. Just tell me how it changed. So it's either a translation or a rotation, because those are the only ones we've talked about so far. Okay, so it's either a translation or a rotation. So tell me if it translates, and if it does it go up or down, and by how much? If it's a rotation, tell me if it's clockwise or counterclockwise. Go try those 4. Okay, so let's take a look at 23, because that seemed to be the one that people had the most issue with. So again, it's a translation. It's a translation if what changes? If the y-intercept changes. All right, it's a rotation if what? If the slope changes. So the slope changes. So then let's take a look at 23. What's changing in 23? Does the y-intercept change? No, because it's +2 in both. So the slope changes. What's the slope? If there isn't one here, what do you assume? It's 1. So that's 1. And then what's the slope over in the second one in g of x? 2/3. Which is bigger, 1 or 2/3? 1 is bigger. So that means your slope is increasing or decreasing? It's decreasing. So that would be a rotation which way? Clockwise. All right, guys, there's a lot of stuff to kind of memorize here, and there's really no way to do it besides just to memorize. Okay? All right. So that will be a rotation clockwise. All right, the last one we're going to talk about is a reflection. What is a reflection? What does that mean? It flips. So for example, if you look in the mirror or you take a selfie, what happens in that picture? It flips, right? So if you have like, I have a black freckle somewhere on my face. I don't know where it is.
It's right there. I see
This
it.
one?
It's right there.
This one? But so it's on my left side, right? But if I were the type of person to take a selfie, which I'm not, but if I did take a selfie, where would it look like in my selfie?
Right here.
Like it was on the right side of my face, right? So you understand when it's a reflection, that means it's like a mirror image. Exactly. So in this one, if this parent function or my f of x function, it just has a negative sign. So what changed? The y-intercept or the slope? The slope changed. And what part of the slope changed? The number or just the sign? So the only thing that changes in a reflection, the slope changes signs. The number does not change at all. So the slope just changes signs. So it just goes from being negative to positive, or if it were positive, it would become negative. Okay, so you're only changing the sign, and that will do a complete reflection of your line. So if it was going positive, now it will go negative. So think about slope, dude. This red line is going positive uphill, and then this the blue line is going positive uphill. The red line is going nice negative, so downhill. Okay, they should be opposite. So then, for example, f of x equals 2/3 x plus 8. If you were reflecting that, just reflecting it, what would change in this equation? The only thing that would change is instead of being positive 2/3, it would be negative 2/3. Does the number change at all? No, because if the number changes, then it's a rotation. Okay, if the number changes, then it's a rotation. If the sign changes, that's when it's a reflection. If your y-intercept changes, that's when it's a translation. So translation is the y-intercept, and slope tells you reflection and rotation. All right, sometimes what's going to happen is you will have multiple things happen at once. So we're going to break this down into 2 steps. We start here with f of x equals x as our parent function. So that's, again, goes through the origin, slope of 1, goes straight down through the middle of our coordinate plane. And we go from f of x to h of x. So h of x becomes 3x. What happened here? Slope did what? Slope went up, which means what happened to the picture of the line? Rotated counterclockwise. Very good. So this is a rotation counterclockwise. And you know that because the slope increased. So the slope increased. And then the second step to g of x, something else happened. So how did we then go from h of x to g of x? What happened here? Just describe to me what happened in the equation. It went +1, which means what happens to the picture of the graph? It translates which way? Up 1. Okay, so that's telling you that it translates up 1. All right, so it translated up 1. So again, if you have y equals mx plus b, this is where you're looking for translations. And this m is where you're looking for rotation and reflection. All right, rotation changes the number. Reflection just changes the negative and positive. So it just changes the sign. All right, rotation changes the number. Reflection just changes the sign. Okay, so an example of what you might do then, I want this one. All right, an example of what you might do would be to say if f of x equals x and g of x equals 2x plus 7. I would say, tell me all the transformations that happened. So how many transformations are we talking about to get from f of x to g of x? What changed? The slope changed, okay. And the y-intercept changed? Okay, so let's look at the slope first. The slope went from what? It was 1 and now it's 2. So if the number changes, is that a reflection or a rotation? Rotation. So that means it rotates which way? Counterclockwise, because the slope got bigger. So rotation counterclockwise. All right, and then you also told me that the y-intercept changed. So what does that tell you? Translated which way? Plus 7. So just translate up 7. All right, and that's it. Why wasn't there a reflection? Why wasn't there a reflection? It didn't change the sign. Okay, so there wasn't a sign change. All right, so at your boards, I want you to tell me, how do you go from A to B? Do you want me to go back? I will. I want you to tell me how you change from A to B. So at your boards, tell me all the transformations that happened. If there's 1, if there's 2, if there's 3, what are they?